we are going to study what is by mathematical expectation of a random variable x. See the definition. Let x be a discrete random variable taking values x1, x2 up to xn with probabilities p1, p2 up to pn respectively. X is taking n values and these are the probabilities. The mathematical expectation of x denoted by e of x is defined as mathematical expectation we denote by e of x and is defined as e of x is equal to, that means expectation of x is equal to x1 into p1 plus x2 p2 plus x3 p3 up to xn pn. In short, we can write summation of xi pi I is equal to 1 to n. This we can write as summation of xi pi. So like this we can define the mathematical expectation of a random variable x. E of x is equal to summation of xi pi. E of x is also called as the expected value of x or mean of x. It is also called as expected value of x or mean of x. Okay, so remember this formula. Expectation of x is equal to summation of xi pi. We have written some remark here. So remark 1 is, if the PMF is in the functional form, that is p of x, then expectation of x is equal to summation of x into px. Sometimes we can write the PMF in the functional form also, that we have studied in our previous chapter. Okay, sometimes we have given the probability distribution in a table form. Sometimes we have given a probability distribution of PMF as a p of x is equal to. So if the PMF is in this functional form, then in that case the formula for expectation of x we write like this, summation of x into px. We can write the expectation of x like this, or we can write the expectation of x like this. So how the probability distribution of x is given or how the PMF of x is given, accordingly we write the formula for expectation of x, that is mean of x. If a random variable takes countably infinite values, then expectation of x is equal to summation of xi pi, but here I takes I is equal to 1 to infinity. Here I takes values I is equal to 1 to n, because x is taking finite values x1, x2, xn. N finite values x is taking. So that's why expectation of x we are written like this. But if x is taking countably infinite values, then in that case we can write the formula for expectation of x as summation of xi pi I is equal to 1 to infinity. So remember this. How many values are there of random variable x? Accordingly we write the formula. Third remark we have written, the value of expectation of x may not be a possible value of a random variable x. So whatever be the value of expectation of x we get, it is not necessary that it will be a value of a random variable of x. For example, when we toss a fair die, okay, when we toss a fair die, what will be the outcomes? The sample space omega equal to 1, 2, 3, 4, 5, 6. When we toss a fair die, we get either number 1 or 2 or 3 or 4 or 5 or 6 on the face of a fair die. And what will be its probability of each sample point? That will be 1 by 6 because it is a fair die. So probability of xi is equal to 1 by 6 for all I is equal to 1, 2, 3 up to 6 because it is a fair die. Suppose we define our random variable x as number observed on the face of a die. Number observed on the face of the die, what are the possible values of x, or what is the range set of x? 1, 2, 3, 4, 5, 6. What will be their probabilities? 1 by 6, 1 by 6, 1 by 6. For each of x value, the probability is 1 by 6. So what will be expectation of x? Expectation of x, that means summation of xi into pi or p of xi, that is 1 into 1 by 6 plus 2 into 1 by 6 plus 3 into 1. This is x1 into p1, x2 p2, like this x6 p6, like this. That addition we have to take. In this 1 by 6 is a common, so we have taken outside. So what we get in bracket? 1 plus 2 plus 3 plus 4 plus 5 plus 6. So finally we get the answer as a 3.5. So expectation of x or mean of x we get as a 3.5. But 3.5 is not a value of x. What are the values of x? 1, 2, 3, 4, 5, 6. Okay, values of x are that. And expectation of x we get as a 3.5. Means it is not necessary that what the expectation of x value we get, that is a possible value of x. It is not necessary. It may not be a value of a x. That we are written in this remark. Okay. So remember this remember this formula. Remember this formula also. Okay. Remember this formula also in case of a countably infinite values. Okay, and then remember this, that expectation of x value may not be a possible value of a x. So you have to remember these formulas. Okay, and write down this on a paper. Okay, take the notes from this video. Okay, like that you can make your practice yourself. So for today we stop here. Okay, and in the next lecture we will see the next part of this chapter. So till then we stop. Thank you.